How does a hydraulic directional control valve work? In a hydraulic drive, a liquid under pressure drives the operation units, such as hydraulic motors and cylinders. In order for a rod of the hydraulic cylinder to start moving forward, it's necessary to direct liquid from the pump into the piston cavity. To push the rod back, it's necessary to direct liquid from the pump into the opposite cavity, the rod one, and allow the liquid from the piston cavity to flow freely into the tank. It turns out that you need to change the routes for the liquid and direct it to different channels. You could do it by different ways. It's quite inconvenient to attach the pipe to the desired channel every time, but it's possible to use valves. Let's install two ball valves to attach the piston cavity with a pump or with a tank. Also, let's attach two similar valves to the piston cavity. By switching the valves, you can make the cylinder rod either move forward or back. It's definitely inconvenient to switch several handles simultaneously, so let's try to combine the valves into one element. Let's make two fitting channels in the shutoff and control element. Now, in one position, the directional control valve will connect the piston cavity with the pump and the rod cavity with the tank, while in the other position, it will connect the piston cavity with the tank and the rod cavity with the pump. Hence, we've got a directional control valve with a rotary spool. The use of such a spool isn't always convenient. There may be difficulties when sealing it. Besides that, when using the rotary spool, it's not always possible to implement more complex schemes. More often, cylindrical spools with belts are used for hydraulic directional control valves. The spool can move in the device's body, block the liquid flow, or connect various channels with each other. Depending on the position of the spool, the liquid could flow from channel number 1 to channel number 2, while channel number 3 is blocked. In the other position, liquid could flow from channel number 1 to channel number 3, while channel number 2 is blocked. Let's make a few more channels in the slab and add belts to the spool. Thus, we'll get a directional control valve, which, as in the first considered case, allows us to control the position of the hydraulic cylinder rod. When liquid is supplied to the piston cavity, the rod moves forward. And when liquid is supplied to the rod cavity, it moves back. By changing the location of the channels in the slab and the position of the belts on the spool, we get a directional control valve, which, in the neutral position, disconnects the cylinder cavities from the pump and the tank, and in two extreme positions, connects one of the cavities to the pump and the other one to the tank. In this case, we've attached 4 lines to the directional control valve, pressure or P, tank or T, and 2 lines attached to the hydraulic cylinder cavities, A and B. Such a directional control valve is usually called a 4-line one. Its spool can have 3 positions, so we've got a 3-positional directional control valve. In the neutral position, the pump line is attached to the drain through a channel inside the spool. Such a scheme makes it possible to offload the pump when the drive doesn't move and doesn't keep the load. Hence, we save energy. When switching, the spool connects the channels and thereby directs liquid to the cylinder piston cavity. The rod starts to move forward. To push it back, it's necessary to switch the spool to another position and direct liquid into the rod cavity, and attach the piston cavity to the drain. But what if the drive has several hydraulic cylinders? Do you need several directional control valves? The scheme shown won't work in such a case. That's why we will try to control one directional valve. The other one will direct liquid from the pump to the drain, so it won't be possible to move the hydraulic cylinder. In this case, you need to select a directional control valve of a different scheme. A 4-line, 3-positional valve with a center locked in the neutral position blocks the pressure and drain lines, as well as channels which lead to the cylinder cavities. When the spool is moved, the liquid is directed to the piston cavity, and the rod cavity is attached to the drain. In the opposite position, the channels are connected in such a way that the liquid from the pump enters the rod cavity and the piston cavity is attached to the drain. Such a scheme is good when the drive is provided with several mechanisms, since they can be used independently. When you switch any directional control valve, the rod of the controlled cylinder will move, because the rest are locked in the neutral position.